Okay, in this video we're going to talk about pulleys and friction. Okay, we're going to combine a couple of things that we've already talked about into one problem or one system and then solve the physics question that it's asking. So, pulleys and friction. Here we go. Okay, we're going to see problems a lot like the one that's shown here. We're going to have a block that's on this desk, and we're going to have a block that's hanging, and it's connected by a rope, and there's a pulley that's changing the direction of tension. So it says here to label all the forces that exist. Let's just start with this M1 block. What's the easiest force to always label first? Okay, force of gravity. How do you find it?
Mass times 9.
Good. Mass times acceleration due to gravity, which we put as g. Okay, guys, is this block M1 moving up and down? No. So what can you say about this force? The normal force is equal to force of gravity. So if you find force of gravity, you found normal force. Okay? Well, gravity is the force that the block puts on the desk, correct? It's going down.
Correct.
Normal force is the force that the desk puts on the block. Okay? And they're equal but in opposite directions. Which law is that? Which one of Newton's? That's the third law. For every action, there's an equal but opposite reaction. Okay, let's label all the other forces that are present here in M1. What do we call this force that's in the rope?
Tension.
Tension. Okay. Now, is there a force that's coming back to the left?
Force of friction.
Good. Force of friction. That's this force that exists between the surfaces of M1 and the desk, right? All right, that's everything on M1. Now let's go to M2. What's the easiest force to label on M2?
Gravity.
Force of gravity. I'm going to call it weight just to mix it up right here. It's equal to mg. And what do we call this force that's going up in the rope?
Force of tension.
Tension. Okay, so capital T there. Now, did we get all of the forces that exist there? Yeah. So in these problems, I'm going to ask you to solve for the acceleration of the system and also the tension in the rope. But let me ask you this right now. Is this tension right here going to be equal to this tension right there? Yeah, it's the same rope here. So when you find tension, you found it for here and also here on the free body diagrams. Now, before we start, what two forces on this system are the most important for you to look at in terms of will it move or not? What's really going to determine whether the system moves? Good. The force of friction here and the weight of this block that's hanging. Okay? Now if this weight is greater, what's going to happen? It's going to pull the system in this direction, right? And so we'll draw in our arrow and say acceleration is positive. Okay? But what if friction was greater? Then it's going to stay at rest. Yeah, the acceleration will be 0. So that's what I want you to compare when you do your free body diagrams is those two forces right there. Okay, there's a lot of steps to these problems, but I think we can go through them pretty quickly. Step number 1 is to find and label all the forces. Okay? So, force of gravity. What do we call this force? Let's go quickly, guys. Normal force. What do we call this force? Force of friction. What do we call this force? Tension. What do I call this force going up? Tension. What do I call this force coming down? Weight or force of gravity. Right? Same thing. Okay. Then decide which force is greater. Friction on M1 or force of gravity on M2. So I want you to circle these two. You're going to decide which one's greater. If there is a net force, what's going to happen?
It's going to move.
It's going to accelerate. We know that from Newton's second law. Show which way the blocks will move. So let's just say this was greater. Okay? So I want you to draw in the arrow. Okay? That means on this M1, when we go to the right, it's positive. But on M2, when we go down, it would be positive. Okay? So keep your sign notation straight. You're going to create two equations, one for each block. We're going to use Newton's second law. Force net is equal to ma, you're going to have two equations again because we have two unknowns. We don't know acceleration and we don't know tension. So we're going to have the two equation system again. Okay. You're going to add the two equations together. Tension should cancel out. Then you'll find acceleration. Then how do you go back and find tension? Yeah, you just plug it in. So I've got an example problem that's in your book. So please be following along in your guided notes here, chapter 4. Okay, this is an example problem. So let's go through it together. Okay, it says the mass of M1 is 4 kgs. I would like to see you guys write that in the block, 4 kgs. Okay, the mass of M2 is 2 kgs. And the coefficient of friction between the block and the surface, between M1 and the surface, is 0.35. So let's put that over here. Mu is equal to 0.35. Okay. Hopefully you have a calculator ready to go. If you don't, get one. Okay? Have a calculator because we're going to put in some numbers here. Okay, let's draw the free body diagram. That's step number 1. What do I call this force coming straight down right here? Force of gravity. It's equal to mg. Well, what's 4 times 9.8? 39.2. Thank you. 39.2 newtons. Okay? Is this block moving up and down, guys? No. So the normal force is equal to what? 39.2 newtons. We know that from Newton's first law. An object at rest stays at rest unless it's acted upon by a net force. Well, the forces are balanced, so the net force is 0. It's going to stay at rest in the vertical direction. Okay, let's draw in the other forces. We got force of friction. Okay? How do you find force of friction? Well, it's equal to mu times what? Normal force. So let's do that. What's 0.35 times 39.2? Good, 13.7. Let's label that and put it on our free body diagram, 13.7 newtons. Okay, and then there's one more force in this rope here, which we call tension, but we don't know what it is. We don't have enough information to solve for it yet. So let's move to M2. I always think the easiest place to start is straight down because that's force of gravity, or this time I'm going to call it weight. Same thing. What's 2 times 9.8?
18.
Is it 19.6?
Yeah,
19.6 newtons straight down. And what's that force coming up in this rope? Well, tension, but we don't know what it is. Don't know what it is yet. Okay. So, we want to find the acceleration of the system. Whenever you see the word acceleration and you're dealing with forces, which one of Newton's laws should we think about? Good. Force net is equal to ma. Which one of Newton's laws is that? That's the second law. Okay. So we know that if we can find the net force, we know the masses of them, we can find acceleration, right? So that's what we're going to do. Except for we have two unknowns. We don't know tension as well. Okay, so we're going to solve for tension. So we're going to need two equations. So let's write first equation here. I don't know, let's just pick M1. Okay? But before we can do anything, we need to compare two forces. Which two forces should we compare? Force of friction on M1 and what? And the force of gravity on M2. Which one's larger? Force of gravity. So is there a net force on this system? Yeah. Will it accelerate? Yes. Which way? Yes. Because this is a larger number, there's a net force that's pointing down here. So it's going to go like this. I want you to draw in that arrow here and put acceleration is positive. That tells us our sign notation. Everything on M1 that goes to the right is positive. Everything on M2 that goes down is also positive. Just keep the same sign notation here throughout. Okay. So on number 1, what's positive? Tension or friction here? Tension's positive. So we're going to have positive tension, subtract off the friction of 13.7, and that's going to equal its mass, which was 4 kgs. And we don't know the acceleration, so I'm just going to call it A. How come when we're So this found net force here, tension minus 13.7. How come we didn't do up and down? Well, there is no net force. It's balanced up and down. But there is going to be a net force left and right. So we just consider that. Okay, let's do the other equation now. Because we have two unknowns, we can't solve this first equation. Let's come up with another equation and see if we can cancel one of our variables out. Okay, what's positive in M2? Is it going to be the force of gravity or tension? Force of gravity, because down was positive, right? So in this one, we got 19.6. Subtract off the tension, and that's equal to the mass. In this case was 2 kgs, and we don't know A. So now we have two equations with two unknowns. Can we solve for it now? We should be able to. What you'll notice, guys, is that tension and minus tension will cancel out. Should always be that way. Yeah. If it's not, you did something wrong with your sign notation. So now let's go, and what's 19.6 minus 13.7? 5.9? Okay, so 5.9 is equal, what's 4a plus 2a? 6a. Now how do I get a by itself? Divide by 6, both sides. Over here it cancels out. So acceleration is equal to what? 0.98. And what's my units? Meters per second squared. Yeah, because it's an acceleration. Okay. So it will accelerate. There is a net force. And that's pretty cool. We can use Newton's laws to figure out the actual rate of acceleration. Now, we're not done because it wants to know the tension in that rope. How would I find the tension, guys? Excuse me, does it matter which one we plug it back into? We can plug it into one or two. I always like to choose where tension is positive, because then we don't have to move tension over to the other side of the equation. So I think that makes it easier. I'm going to solve for it up here just because there's more room. Tension minus 13.7. So I'm simply just writing equation 1 up here again. Is equal to 4 times A. Now we do know A, so I'm going to put it in 0.98. Okay. So let's take 4 times 0.98. 3.92, thank you. 3.92 is equal to tension minus 13.7. Guys, how do I get tension by itself right here? Yeah, let's add 13.7 to both sides. Okay. 17.62? Perfect. So tension is equal to 17.6 newtons. Yeah, tension is a force, so your units is going to be in newtons. Okay, now before we finish the problem, we're done doing the calculations, but let's look at this, guys. And what I would suggest that you do is to plug tension back in here in your free body diagram and just put it in 17.6 here and 17.6 here. Now, if this was the actual numbers on the magnitudes of the forces, which is greater, 13.7 or 17.6? So there's a net force and it's going to be moving right. Well, that's what we said. What's greater, 19.6 or 17.6?
19.6.
19.6, so it is going to move down. Does that make sense?
Yep.
Okay.
Yep.
So that's the example problem. Now, I've got a couple of problems in your workbook, in the guided notes, for you to try. Let's start with practice problem number 12. So if you're watching the video, please try this on your own first. Try it on your own, and then when you get an answer for acceleration and tension, then hit play and see if you got it right. Okay, so let's see if you guys got this one correct. M1 is 20 kg, so let's put that in the actual block over here. And M2 is 20 kgs. Okay. And the coefficient of friction between M1 and the table, mu, was equal to 0.35. Okay, step 1 is to do the free body diagram for each of them. I'm going to start with M1 and just do force of gravity, which is equal to mg. So 20 times 9.8 is 196. 196 newtons. Now, we know that this block M1 is not moving up and down, so the normal force has got to be balanced with force of gravity, so it's 196 as well. Okay, we know that there's going to be some friction, so I'm going to call this one force of friction, and the rope here, that force that's present in a rope is called tension. We have enough information to find force of friction because it's mu times normal force, and we have mu, it's 0.35, times the normal force of 196, and that gets me 68.6 newtons. That's what force of friction will be. Okay? And we don't know what tension is yet, but we'll be able to solve for it later. M2, let's draw the free body diagram. So weight is equal to mg. Again, it's 20 times 9.8, which was 196 newtons. And we don't know what tension is in this string yet, but we'll be able to solve for it later. So that's step one, is to draw your free body diagram and label all the forces that you see there. Then we're going to compare two numbers here. Force of friction on M1 and the weight on M2. And ask yourself which one's greater. It looks like it's pretty obvious that M2, the weight of M2, is a lot greater than the friction on M1. So this is going to be a net force, and according to Newton's second law of motion, if there's a net force, it will accelerate. It's going to move in this direction. Okay? So what that tells us is our sign notation. Put acceleration is positive in that direction. So with M1 coming to the right, that's positive. M2 going down is positive. So keep the sign notation consistent there. Now, we want to know what the acceleration of the system is and the tension in the string. So let's solve for the acceleration. Whenever you see the word acceleration, you should think Newton's second law, force net is equal to ma. We're going to have two unknowns though, because we don't know tension and we don't know acceleration. So we're going to come up with two equations. And the first equation, it doesn't matter which one you choose first. I always do M1 first. Let's look at block M1 here. There's not going to be a net force going up and down. 196 is balanced with 196 down. So what's contributing to the net force is going to be what's going left and right. Tension is going to be positive because we said to the right was positive. So tension, and then to get a net force, we need to subtract off what's going in the opposite direction, 68.6. That's equal to the mass, which was 20 kgs, times A. Okay, and this is a single equation, but we have two unknowns. So we can't solve it. Let's get another equation so that we can. Let's go to M2. What was positive here, guys? Tension or the weight? We said that down was positive, so now we're going to put positive 196 and subtract off what's going up in this case was tension. And that's going to give us our net force. And so now we just got mass, which was 20, times the acceleration. Okay, if we add these two equations together now, we should be able to cancel out one of our unknown variables. What's positive tension minus tension? Well, it cancels out. So then we get 196. 196 minus 68.6 is 127.4. Thank you. You got it. 127.4 is equal to, what's 20A plus 20A? That'd be 40A. Okay. Now we just solve this equation. How do you get A by itself?
Divide them.
Divide by 40. Both sides? Okay. So it cancels out on the right. Good. So acceleration is equal to 3.19 meters per second squared.
Is it okay if we put 3.18?
3.185. Yeah, I just rounded that to 2 decimal places. So.
Alrighty.
Yeah. All right. Now that we have the acceleration, guys, can we solve for tension?
Yeah.
Yeah, we just plug it back in for A. Again, I always do it where tension is positive. So I'm going to take this first equation here and put it up here. So tension minus 68.6 is equal to 20 times A. And since we already have A, we know that A is 3.19 meters per second squared. Let's plug it in. Good. So 63.8. 63.8 if you take 20 and times it by 3.19. And so tension minus 68.6 is equal to that. How do I solve for tension, guys? Add. We're going to add 68.6 to both sides. Okay, over here, that cancels out. So tension is equal to... Perfect. 132.4 what? Newtons, yeah. Tension is a force, so please put newtons as your units. Okay. Yeah, if it's just a rounding issue, I'm not going to be too concerned. We're just learning it. So, yeah, if it's just a rounding issue, it's no big deal. Okay, but before we go on, let's plug in tension. 132.4. 132.4 newtons. Okay, let's look at M1. Is tension greater than force of friction? And it is. So this block will move to the right, which is what we said it would do. Is 196 on M2 greater than 132.4? And it is, so it is going to move down. So that does make sense. Okay, one final practice problem in your guided notes. And that's this one here. So practice problem 13, please try it on your own. Hit pause on the video and try this one on your own first. When you have an answer for acceleration and tension, please hit play and see if you got it right.
Okay.
Okay, let's see if you got this one correct. So practice problem number 13, it says the mass of M1 is 8 kg. So I'm going to put that in the box, 8 kgs. And the mass of M2 is 3 kgs. And the coefficient of friction between M1 and the table, so this coefficient of friction right here, mu, mu is equal to 0.5, 0.5. Okay, it wants us to find the acceleration of the system and the tension in the rope. So I'm going to take that off just to leave us some more space here. First step is to draw the free body diagram. Okay, let's do that. So we got the force of gravity coming down here, which is equal to mg, the mass times the acceleration due to gravity. So that is 8 times 9.8, 78.4, thank you. 78.4 newtons is there. Now is M1 moving up and down? Nope, so that, according to Newton's first law, tells us the forces have to be balanced. So the normal force is 78.4 newtons. Okay. We know that there's going to be some friction here. So this is the force of friction. And it's equal to mu times normal. Well, I've got both of those, so let's figure out the magnitude of force of friction. We're going to take 0.5 and times it by 78.4. Good, 39.2. 39.2 newtons. All I did was take this coefficient of friction and times it by the normal force, and that gave me 39.2 newtons. Okay. There's one more force on M1. What is it? Tension in that rope there. Okay. That's it that I can at least get a magnitude as of right now for M1. So let's go to M2. What do we call this force coming down? Force of gravity or weight. It's equal to mg. So we're going to take 3 times 9.8. I get 29.4. 29.4 newtons. Okay, and we know that there's a force coming up called tension. Okay, so after step 1, which is to do this and get your free body diagrams all labeled and the magnitudes found, we need to compare two numbers. We're going to compare the force of friction on M1 and the weight, or the force of gravity, on M2. Now in this case, which one's greater? Yeah, this force of friction is greater. So let's think about that. If the force of friction is greater than the weight here, is this thing going to move? No. And the answer is no. So that's pretty easy. Acceleration is going to be what? 0 meters per second squared. Yeah, it's not going to move unless there's a net force, and you've got to get more weight down here in order for it to start moving, right? What if this weight was 39.4? Would it move? Yeah, then there would be a net force. But since it's only 29.4, the force of friction is greater. So, and remember, does friction ever cause something to move? No, it just prevents it from moving. It opposes motion, right? It opposes motion. All right, so now we really got to do some thinking because we don't know tension. Okay? Let me ask you this, guys. Does M1 right here contribute to tension in this rope? And the answer is no. M1 is not contributing to tension in that rope. What is contributing to the tension?
Is it M2?
Yeah, it's the weight of M2 that's causing tension to be in this rope, correct? So if we found the weight of M2, let me ask it to you this way. Let's use Newton's laws of motion. M2 here is not moving, it's at rest. So what does that tell us about the forces that are acting on it? They're balanced, yeah, they're equal. So the tension up has to be 29.4, right? 29.4 newtons, according to Newton's first law. So tension is equal to 29.4 newtons. How many of you guys got that right? Good job. Okay, hopefully this makes sense, guys. This is a great way to apply Newton's laws of motion to a physics problem. We've got friction, we've got a pulley, we've got all the forces that we've talked about up in this class up to this point in this problem. So it's a great problem. Anyway, I want you guys to open up your books now, your student workbooks. There's a worksheet called Pulleys Worksheet number 2 that will give you some more practice with this. It's called Pulleys Worksheet number 2. So please go there now and complete that. And hopefully this video helped.